Right. Good afternoon, all of you. Right. In the last class, we started colligative property. In that colligative property, we learned RLVP, that is relative lowering of vapor pressure. Correct. And in that one numerical, we did two numericals from relative lowering of vapor pressure. We did. Now today our discussion will be on elevation in boiling point. Right. Today's date. Right. Heading elevation in boiling point. The second colligative property. Important, right? Elevation in boiling point. Now, boiling point we discussed in the introduction, the temperature at which vapor pressure of a liquid is equal to 1 atmospheric pressure is called boiling point, we learned. Now observe here, in the last class I told you, consider this is of solvent, this is of water I took, this is of solvent, and to this I have added solute to it. Then yesterday I taught you, when you add solute to the solvent, it makes a solution. This is solution I took. Now, and the last class I told you this will be P naught, that is vapor pressure of pure solvent. This is vapor pressure of solution. Now, when we add solute to solvent, what happens? See, no doubt vapor pressure comes more than vapor pressure of solvent. But you remember boiling point of the solution is inversely proportional to vapor pressure we discussed in the introduction of evaporation. That means when you add solute to solvent, what happens? Boiling point of solution gets elevated. That means if you consider boiling point of solvent to boiling point of solution, the boiling point of solvent comes less, whereas boiling point of solution comes to be more. That means what is happening when you are adding solute to solvent, boiling point of solution gets elevated. That is what we are writing here, elevation in boiling point. Understood? So when you are taking vapor pressure of solvent comes to be more compared with solution, whereas boiling point when you compare, as it is inversely proportional vapor pressure, so when we add solute to solvent, boiling point of solution comes to be more compared with what? Solvent. Understood, all of you? So hence what we say, when we add solute to solvent, make a note. When a solute is added to solvent, boiling point of solution gets elevated. Abbreviate with BP. Boiling point of solution gets elevated. That means boiling point of solution comes to be more compared with water, boiling point of solvent. Therefore, elevation in boiling point we represent with delta TB. So what is elevation in boiling point? It is the difference between boiling point of solution minus boiling point of solvent. Boiling point of what minus water? Boiling point of solution minus boiling point of solvent. Understood, all of you? So make a note, clear it's a. So when we add solute to solvent, boiling point of solution gets elevated. Hence, elevation in boiling point is given by delta TB is equal to boiling point of solution minus boiling point of solvent. This you keep it in box. Up to this is clear? Everyone understood? So elevation in boiling point is nothing but when we add a solute to solvent, the boiling point gets elevated. So boiling point of solution comes to be more compared to boiling point of solvent, and the difference between the two will give elevation in boiling point. Copy this. This is what, student, yesterday we discussed. This is vapor pressure. Vapor pressure of solvent comes more. then vapor pressure of solution, whereas boiling point comes opposite. Since vapor pressure is inversely proportional to boiling point. Recollect this we discussed in evaporation time. Copied all of you. Now observe here all of you. Now see this elevation in boiling point which we are writing with delta TB. Now what is delta TB now onwards? Elevation in boiling point. It will be directly proportional to molality. What is small m? Small m is molality. We learnt in the last class, recollect. Molality is the number of moles present in 1 kg of solvent. So the elevation in boiling point will be directly proportional to molality. Removing this proportionality, we multiply with a constant that is called Kb. Now see a new constant we are getting important, and this new constant Kb is called Ubilioscopic constant. This is called Ubilioscopic constant. Ubilioscopic constant. Or this is also called molal elevation constant. See, this Kb is also called molal elevation constant. So very important. In JEE they can ask you how this Kb value. This Kb is called molal elevation constant, or we also call Ubilioscopic constant. Now what we define for Kb? See, in order to define Kb, let us assume molality be 1 mole. Are you getting my point? Let us define Kb. To define Kb, what we assume, let the molality be 1 mole per kg. You are familiar, no? The number of moles present in 1 kg. If molality is 1 mole per kg, tell me students, then what should I write? Del Tb is equal to Kb can be write? Do you agree all of you? So elevation in boiling point is given by Kb. That means what we define? The elevation in boiling point produced when 1 mole of solute is present in 1 kg of solvent is called Ubilioscopic constant. So what is the definition of Ubilioscopic constant? The elevation in boiling point produced. The elevation in boiling point produced when how many moles of solute is dissolved? When 1 mole of solute is dissolved in 1 mole of solute is dissolved in 1 kg of solvent. Are you following all of you? When 1 mole of solute is dissolved in 1 kg of solvent, then it is known as what? Ubilioscopic constant, or we call molal elevation constant. This is important. Put star mark for Ubilioscopic constant. Clear for all? So simple Kb is nothing but the elevation in boiling point when it is produced when 1 mole is solute is dissolved in 1 kg of solvent. Clear, understood all of it? Right. Now what are the units of Kb? Copy this. And in exam, units of Kb, what will be the unit of Kb? Now bring Kb student. Kb is equal to what we write? Delta Tb by m, no? Copied all of you up to here. Now I continue in the next page. Writing delta Tb is equal to what we wrote? Kb into m we wrote, no? Now bring Kb from this. Kb is equal to what should I write? Delta T by m, no? That means what will be the unit for Kb if they ask? Kelvin. Temperature is measured in Kelvin, no? Kg per mole. You know, molality units. This will be the unit of Kb. Kelvin Kg per mole. So the unit of Kb will be Kelvin Kg per mole. This is important. Put star mark. Unit of Kb. Clear, students? Right. Now see one important point here. This Kb, which we are calling Ubilioscopic constant, it will vary from solvent to solvent. That means if I am taking water, water will have 1 kb value. If I am taking benzene, benzene will have a particular kb value. That means kb value depends only on nature of solvent but not on nature of solute. Irrespective of solute you dissolve. Suppose in the water I am adding urea and I am adding another substance sucrose, or I am adding NaCl I am adding. So whatever the solute you add, my kb value will never change. That means kb value doesn't depend on nature of solvent, nature of solute. But solvent to solvent it will vary. Understood, student? What I am saying is kb value depends on the nature of solute, it will won't vary, but depends on nature of solvent. It varies only from solvent to solvent but not on solute. Clear? So make a note, kb is independent on what? Very important. kb, once in exam they asked a question, when molality of the solution is doubled, what happens to kb value? Even if you change concentration, what is the amount of solute you add, kb value will be fixed. So kb is independent on what, student? It is independent on nature of solute. So irrespective of the solute, what the solute you are adding, it doesn't depend on nature of solute, but it varies from solvent to solvent. Understood all of you? This is what important, kb. So as I told you in exam, they asked when molality of the solution is doubled, what happens to ubilioscopic constant? And option they given. So in the option you have to choose, it is independent. It cannot change. kb will not depend on nature of solute. Clear? Now this kb value to find, we write one relation. It depends on R into T naught square by 1000 into latent heat of vaporization. So this is the relation in order to find kb. That means kb value, ubilioscopic constant, depends on what? The R, that is boiling point of solvent, as well as what? Latent heat of vaporization. Now this latent heat of vaporization, you know in thermodynamics, the heat required to convert 1 gram of water into vapor. What is LV? Latent heat of vaporization. What we define for latent heat of vaporization? The amount of heat required to convert 1 gram. 1 gram of water to convert into what? Vapor is called latent heat of vaporization. This is important. So from this relation we may get numerical on kb. Keep it in box. Where R is universal gas constant, T naught is boiling point of solvent. Now tell me, student, if water is solvent, what should I consider? 100 degrees Celsius. If you know a boiling point, if it is water, what should be the boiling point? Water boils at 100. When we convert in Kelvin, we have to take 373. R is universal gas constant and LV is latent heat of vaporization. Clear? This you put it in box, important. Understood? Now I want amount of heat required for 1 mole of water. What is 1 mole of water? Weighs 18 grams. 18 grams to convert into vapor. This is for 1 gram we wrote. So if I write for 1 mole of gas, see what should we write? kb is equal to R into T naught square into molar mass by 1000 into enthalpy of vaporization. See, saw the difference between the previous one and this one? This is for 1 mole of water to convert into vapor. You studied in thermodynamics chapter. Enthalpy of vaporization means what? You remember in 11th class in thermodynamics, enthalpy of vaporization is, this is for 1 mole of water. That means to convert 18 grams of water to into 18 grams of vapor. Liquid to convert 1 mole of water. This previously we wrote for how many gram? For 1 gram we wrote. See. This is for 1 gram. For 1 mole to get what we do, we divide with molar mass. So m by enthalpy of vaporization. So what is this m, students? Molar mass. Here. Now if I consider for water this have to take 100, no, on substituting, as I told you, Kb value will be fixed for a solvent. For water it comes 0.53. This will be the ubilioscopic constant for water. If it is for benzene, we get another value substituting this. What will be the unit? Kelvin kg per mole. This will be the value Kb for ubilioscopic constant value for water. This is fixed value for water. In the problem they will give you, if it is other than water, they have to mention. This is ubilioscopic constant value for water. How much? 0.53 Kelvin kg per mole. Understood, student? So this is ubilioscopic constant. Till once again see what we learned till now. So till now what we wrote, elevation in boiling point is nothing but it is the difference between boiling point of solution to boiling point of solvent, and this elevation in boiling point is directly proportional to molality. You remove the proportionality, we multiplying with a constant. That constant is called ubilioscopic constant or molar elevation constant. And this Kb, what we define, the elevation in boiling point produced when 1 mole of solute is dissolved in 1 kg of solvent. This is the definition of Kb. And what will be the unit of Kb? Unit will be Kelvin kg per mole, and Kb will be independent on nature of solute. It doesn't depend on nature of solute, and this Kb is given by R into boiling point of solvent square by 1000 into latent heat of vaporization. What is latent heat of vaporization? The amount of heat required to convert 1 gram of water into 1 gram of vapor. This is latent heat of vaporization. And if you want to convert for 1 mole, then we take what? Enthalpy of vaporization. This is for 1 mole of water. See the difference between latent heat of vaporization to enthalpy of vaporization. Substituting the values for water, we are getting a value, how much? 0.53. Unit will be Kelvin kg per mole. Understood, student? This is what will be elevation in boiling point. Clear? Copied all of it? Simple. So in the numericals, we can get these relations from Kb. Copied all of you? Clear all of you? Is it? And solving questions from material. Everyone start doing solution chapter. And from Monday onwards, as you know, 16th onwards, we are having vacation. No, for that homework has been allotted. There have been allotted topics till colligative properties. From the material day wise, we have given homework. Once see that schedule will be shared to you. Based on that, work on that. Day wise, we have given from 16th, I think so. From 16th, we have given day wise one small topics. Till now, the colligative properties what we did. Clear? This is ubilioscopic constant. The value of ubilioscopic constant for water will be 0.53 Kelvin kg per mole. Now observe here, coming to next. When we plot the, and what is that relation we wrote, student, just now? This elevation in boiling point which we wrote with delta TB, no? That is equal to what we wrote, Kb into small m we wrote. Correct? What is small m? Molality. Now what is molality, students? We learnt in the introduction, the number of moles present in 1 kg of solvent. So this I can elaborate. See how I am writing, del TB is equal to Kb into, and number of moles what we write, mass by molar mass, that is small w by small m, mass of solute by molar mass of solute into 1000 by weight of solvent. This is the relation. From this relation we get numericals in JEE mains as well as in NEET. That means in the problem they give you mass of solute to you and weight of solvent to you, and they ask you to find boiling point of solution, or they can ask you to find molar mass of solute. Now this del TB, what minus what should I write? Boiling point of solution minus solvent, no? Because solution gets elevated. Whose boiling point will be more, student? Solution will be more, no? So, and in exam, if they don't give boiling point of solvent, we have to consider 100 degrees Celsius. It is a universal solvent, no? Water, if it is water, no need to give the boiling point. Its value will be how much, student? 100 degrees Celsius. This should be equal to Kb. Kb value, if it is water, they will give you 0.53. So, Kb into what we write, mass of solute into 1000 by molar mass into weight of solvent. This is the relation. Keep it in box. Understood all of you? This is the relation, and mention the terms. What is TS here? Boiling point of solution. Boiling point of solution. What is T naught? Boiling point of solvent. This is solvent boils. If it is water, 100 degree. If it is other than water, they will provide. This is boiling point of solvent. Boiling point of solvent. And what is Kb? Kb already we done. Ubilioscopic constant. What is small w? Weight of solute. What is small m? Molar mass of solute. Molar mass of solute. And what is capital W? Weight of solvent. Weight of solvent. So in the problem, everything will be given. They will ask you to find, suppose if boiling point of solution would have been asked, they will give you weight of solute to you and weight of solvent to you. Molar mass we can find out from the solute. Clear, students? This is what? Elevation in boiling point. Simple. Copied all of it. Keep it in box. Important. In this numericals we get in JEE mains as well as in NEET exam. Copied them all. Now let us draw a graph. See, when we plot a graph between, on the y-axis you take vapor pressure. Here you take vapor pressure on the y-axis. On the x-axis you take temperature. Now see, I am considering here two dots. See, this is dot 1, dot 2. Now tell me, among the upper dot and lower dot, who will be the solvent, who will be the solution? The upper dot do you consider for solvent or lower dot you consider for solvent? Vapor pressure of whose value will be more, student? Solvent will be more, no? Vapor pressure of solvent will be more than vapor pressure of solution, no? So upper point corresponds to solvent, lower point corresponds to solution. And you remember Clausius-Clapeyron relation. Vapor pressure increases exponentially, we learned. With increase in temperature, vapor pressure is increasing, and upper one should be taken for whom? Solvent, no, student? This is in graphical approach, they also ask in exam. Upper one corresponds to whom? Solvent. The lower one corresponds to whom? Solution. Boiling point, vapor pressure of solution comes less. And this point corresponds to atmospheric pressure. See, this point touching this axis will give BP. At atmospheric pressure, no, water gets boiled. So this is atmospheric pressure. When it touches this axis at 1 atmosphere, this point corresponds to what they ask. See, a graphical approach, this point corresponds to boiling point of solvent. Getting idea? And this graph, this point corresponds to what, student? Boiling point of solution. That means whose boiling point has been more? The boiling point of this solution is more compared to boiling point of solvent. The same thing, no, what we wrote, as solute is added, boiling point of solution gets elevated, and this difference will give what, students? Elevation in boiling point, that is delta TB. This difference will give elevation in boiling point, that is solution minus solvent. Draw this graph. Clear all of you? So this point is for solvent and this point is for solution. As vapor pressure of solvent is more. But boiling point, when you compare, boiling point of solution comes more. Inversely proportional. Vapor pressure, keep it in mind, is inversely proportional to boiling point. If you remember this relation, you won't do any mistakes in this. So on this gap will give elevation in boiling point. This is elevation in boiling point. Understood? So this is what with this elevation in boiling point. Second colligative property completed. First colligative property we learned RLVP. Now I show you from the introduction once again till now what we learned. So in the definition we wrote a elevation in boiling point, and this elevation in boiling point is directly proportional to molality, where Kb is ubuloscopy constant. Ubuloscopy constant definition we did, and what are the units of Kb? And Kb is independent on nature of solute, and for water the value of Kb comes 0.53, and on elaboration of this we get the relation del Tb is equal to Kb into mass of solute by molar mass of solute into 1000 by weight of solvent. And in this elevation in boiling point, you have to consider solution minus solvent. So solution boiling point will be more, and for water, if they don't mention, you have to take 100 degrees centigrade. And the graph we get a plot like this. In exam graphical approach also they ask. Now write one question. One from numerical you write. Find the boiling point of solution. Write one question on elevation of boiling. Find the boiling point of solution when 0.5 grams of urea. What is the formula of urea, students? NH2 CONH2. Is dissolved in 500 grams of solvent. Here solvent is water, and I am giving Kb value. Kb value is 0.52 Kelvin kg per mole. Now see, question understood what I am asking. What will be the boiling point of solution I want? So how many grams of solute is been added? 0.5 grams of urea is dissolved in 500 grams of solvent. And what is Kb? Kb given to you, ubuloscopy constant. So direct substitution. What is the relation? Del Tb is equal to Kb into small w upon small m into 1000 upon capital W. No? Now this boiling point, elevation in boiling point, what we write? Solution minus solvent. We want to find boiling point of solution. Solvent is to be taken how much? 100. Correct? 100, and ubuloscopy constant is 0.52, and mass of solute given to you 0.5 into 1000 by molar mass of urea. Urea molar mass, when you find out, it comes 60. Check. Molar mass you can find out by adding algebraic sum. Of what weight of solvent? 500 he has given. So substitute this 500 get cancelled. 5 will cancel by 2. This 2 will cancel by 30 times. And this 5 ones are 5 6s are. Now 6 when you cancel off 2 3s are, 2 2s are 4, 2 6s are. Now this comes how much? Ts minus 100 is equal to 0.26 into 0.1 upon 3. Correct? So this comes how much? 226. That is Ts minus 100 is equal to, can I write this as 26 into 10 power minus 3 by 3, students? Now divide 3 upon 26. 3 8s are 24. 2.36 are 18. So here 10 minus 8 2, 8.66. So 8.66 means this is coming 8.66 into 10 power minus 3. Means you move decimal after how many digits? 4 digits. 8.66 means it is coming 0.0866. This is Ts minus 100. Now Ts comes how much? You bring this minus 100 to that side. So 100 plus 0.0866. That comes how much, student? 100.00866. This will be the boiling point of solution. So from 100 you add what? 0.0866. That comes how much? 100.0866. This will be 10 will be reduced. So understood, this is the boiling point of solution. Is boiling point has been elevated or not? Third, and direct substitution. Clear for all? So mass of solute given, mass of solvent given. This will be the answer. What will be the boiling point of solution? 100.086. Check. Clear, student? This is what elevation in boiling point completed. Now next colligative property we have to discuss depression in freezing point. Copied all of you? Clear from all of you? Direct substitution, it is numerical. See, in this mass given, mass of weight given. Substituting final answer, check, you have to get 100.086. Unit will be degree centigrade. If it is given in Kelvin, examiner wish. He can give in Kelvin also in option, then add 273.15. Done. Clear, Amala? So with this RLVP, relative lowering of vapor pressure, we completed, and elevation in boiling point. Now I am going for third colligative property, depression in freezing point. Right, next heading, depression in freezing point. What is the third colligative property? Depression. Depression in freezing point. The name itself says depression means what? Freezing point of solution gets depressed. Depression in freezing point. Now student, what is meant by freezing point? First you have to know freezing point is the temperature at which the vapor pressure of liquid is equal to vapor pressure of solid. That is ice conversion. Depression in freezing point, and this is shown with what? A delta TF. Now what is this depression in freezing point? Suppose see, this is solvent, no? So this solvent I am adding solute. So what it becomes solution, it makes, no? So when we compare the freezing point of solution, this freezing point of solution gets depressed. That means freezing point of solvent will be more, whereas freezing point of solution will be less. Getting idea? Just opposite to boiling point. So here make a note. When a solute is added to solvent, are you following? When a solute is added to solvent, what happens to freezing point of solution? The freezing point of solution gets depressed, means decreases. When a solute is added to solvent, the freezing point of solution will be less than whom? The freezing point of solution, the freezing point of solution will be less than freezing point of water, less than the freezing point of the solvent. Understood? That means what we write, suppose if freezing point of solvent is T0 and freezing point of solution is Ts. Now whose freezing point will be more? Just opposite. In case of boiling point, solution boiling point would have been more, no? But here see, freezing point of solvent will be more than freezing point of solution. Getting idea? Freezing point of solvent will be more than freezing point of solution. Clear, students? So then how we write depression in freezing point? The depression in freezing point is given by, copied up to here everyone. Is it clear up to here everyone? Clear, no? So depression in freezing point is nothing but when we are adding a solute to solvent. This is, imagine this is solution. So what is happening to freezing point of solution? Freezing point of solution will be depressed. That means solvent freezing point will be more compared to solution, and therefore depression in freezing point is given by del TF. Now this del TF can be written what, students? Freezing point of solvent minus freezing point of solution. So keep it in mind, this is freezing point of solvent will be more minus freezing point of water solution. Clear? Understood all of? Now see, this del TF which we are calling depression in freezing point will be directly proportional to molality, the same as what we took in the previous. It is proportional to molality. Now remove the proportionality, we multiply with a constant. Now what is that constant? See, del TF is given by Kf into M. Now see, another constant we are getting, important, what is this called? Cryoscopic constant. What is this constant called? A cryoscopic constant, or we are even call molar elevation constant. Sorry, molar depression constant. Molar depression constant, just like ubilioscopic constant. Molar depression constant. Saw the difference between previous one and this one? Previous one is Kb. Kb is ubilioscopic constant. This is called cryoscopic constant, or what is the other name? Molar depression constant. And what we define for molar cryoscopic constant? Same. Let us assume molality be 1. If molality is 1, what should we write? The depression in freezing point will be equal to Kf. Understood? Hence, what we define for Kf? The depression in freezing point produced when 1 mole of solute is dissolved in 1 kg of solvent. No, molality is nothing but what? Number of moles present in 1 kg. When 1 mole of solute is present in 1 kg of solvent, then the depression produced is called Kf. Copy this. Clear? Are you following? So this is called cryoscopic constant, or what we call a molar depression constant. Following all of you, right? Now write definition of Kf. Copy it up to here, everyone. Now write definition of Kf. What we define for Kf? Write definition. The depression in freezing point produced. Depression in freezing point produced when how many mole of solute, student? Produced when 1 mole of solute. 1 mole of solute is dissolved in how much volume of solvent? In 1 kg of solvent. Correct? That is called cryoscopic constant or molar depression constant. Then what the units Kf will have? Units of Kf. Now tell me, Kf is equal to what we write, student? Del Tf by M, no? Same as we previously we wrote, del Tb by M we wrote, no? Now what will be the unit? Kelvin. Same as the unit of Kb, Kelvin kg per mole. This will be the unit of Kf. Kelvin kg per mole. Now here also this Kf value will be independent on nature of solute. What is the solute you add? In water, Kf will remain constant. So here make a note, Kf is independent on what? Nature of solute. It doesn't depend on nature of solute, no? Same as what we learnt in Kb. It doesn't depend on nature of solute. But solvent to solvent, this value of Kf will vary. And this Kf can be found by using the relation. Previously we wrote a relation, you recall? So this Kf is given by R. What is R? Universal gas constant into freezing point of solvent. Where? By 1000 into latent heat of fusion. You know, fusion in thermodynamics first year you studied. The amount of water to convert it into ice. This is called LF. What is LF? Latent heat of fusion. Latent heat of fusion. So what is fusion? The amount of heat required to convert 1 gram of ice into water. Fusion. And this relation you keep it in box. So where R is universal gas constant, T0 is freezing point of solvent, LF is latent heat of fusion. That is the amount of heat required to convert 1 gram of solid into water, ice to convert into liquid. Now if I want for 1 mole, what is that for 1 mole means? We call enthalpy of fusion. Then what we write? Kf is equal to R into T0 square into capital M. What is capital M? Molar mass by 1000 into enthalpy of fusion. See, this is for 1 mole. So what is this enthalpy of fusion? This is enthalpy of fusion for 1 mole. For 1 mole means how many grams? For 18 grams for 1 mole of water. These relations are important. This is what a cryoscopic constant. Following them all of you. Now see this value Kf, if you find for water, its value for water comes 1.86. This is fixed value for water. Unit will be Kelvin kg per mole. This is the value of Kf for water. As I told you, it will vary from solvent to solvent. Kf for water will be 1 point. In the numerical, they will mention the Kf value, but for water, generally there is no need. Sometimes they don't mention. You have to remember for water, it is 1.86. If it is other than water, they have to provide the data. Copy it, students. It is understood. No? Now see, this del TF last 2 minutes. This del TF what we wrote? Del TF is equal to Kb into M we wrote, no? So we elaborate this. Now tell me what you take del TF, student, solvent minus solution or solution minus solvent? Here you have to be careful. So solvent minus solution. See. This T0 is freezing point of solvent. Solvent will be more, no? And this is freezing point of water solution. Getting idea all of you? This will be equal to Kb into molality. You are familiar, no? What we wrote? Mass by molar mass into 1000 upon capital W. This is the relation. In this relation, you get a numerical in exam. Where Kb is biblioscopic constant. What is small w? Weight of solute. And this is molar mass of solute. What is capital W? Weight of solvent. Same as what we wrote in boiling point of solution. In this relation, we get numerical. Understood, student. This is what colligative property, depression in freezing point. And tomorrow we continue when graph is there for this. Tomorrow we discuss that. After that we go for osmotic prayer. That tomorrow we will discuss. And last one part is there, want of factor, abnormal molar mass. So with that the solution chapter gets completed. By hardly 2-3 days we will complete. And your job is what, the concept of what I am teaching, you have to start solving, and holiday work will be allotted to you from 16th day to day wise. We will provide you the day wise what we make schedule, that you have to complete it, and you have to produce when you come to hostel, where else you are. So this is what I am ending the session, boys and girls, right? Bye.